Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to recognize the various ways that a function can be represented, how to find function values of functions, how to use function notation to find points on a graph, how to manipulate the context of a problem and find solutions to fit another context, to apply functions and their various representations to real-world applications, to examine functions and compare their function values and behaviors in given intervals, to recognize the characteristics of periodic functions and recognize them as repetitive intervals, to perform mathematical operations on functions to determine their function values, and to perform algebraic operations on functions to determine their function values. How are we learning it? Through the Reasoning with Representations of Functions Review Part 3 notes and the Reasoning with Representations of Functions Review Part 3 assignment. When can we use this information? To practice examining problems from all angles and examine the various ways to solve the problem, to find solutions to any kind of math problem, to examine how previous experiences and previous solutions can lead to positive outcomes for current issues, to recognize repeated patterns in daily tasks and their common solutions, and to plan for changes in your electricity bill when a new rate takes effect. How do you know you learned it? By getting a score of 4 on the Reasoning with Representations of Functions Review Part 3 assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. Next, we'll do our weekly raffle. After that, we'll go over the Reasoning with Representations of Functions Review Part 3 notes, and I'll give you time to complete the Reasoning with Representations of Functions Review Part 3 assignment. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Reasoning with Representations of Functions study guide and any incomplete assignments that you may have. Let's take a look now at the Reasoning with Representations of Functions Part 3 notes. The notes begin with the learning goals and success criteria. Now, what is a function? A function is a relation in which each element of the domain is paired with exactly one element of the range. So that means that for every x, there's exactly one y that matches with that x value. If there is more than one y to match up with an x, then it is not a function. So let's look at some examples here. So we have a bunch of dots here. We have tables, we have equations. We can see it in various different ways. But if we notice here, there's an x value here at x equals negative 4, and y is negative 3. There's no other y value that matches with it. Same thing with all of these. Here we have a straight line. I can pick any x value, and there's only one y that matches it. Here, again, same thing. Now, non-functions look something like this. So notice, if I pick an x value like x equals 0, so when x is 0, y is this one, it's this one, and it's this one. So there's 3 different y values that match up. That doesn't work. Same thing here. If we look here at this x value right here, there's 2 values there for y that make it true. So that doesn't work. Same thing here. If I pick x equals 0 here and here, there is 2 points. So again, not a function. Now, can we represent a function verbally? Well, functions can be represented in many different ways. Here, the first one is symbolic representation. An example of that would be f of 3 equals 7. So what we're saying is when x is 3, y is 7. We can write it as a mapping. So we could say 3 is mapped to 7, meaning that when we plug 3 in for x, we get 7. We can do it graphically. So the point 3, 7 belongs to the graph of function f. So we could say it that way. We could say it as an image. So 7 is the image of 3, meaning 7 is the result when we plug 3 in. So it's just the backwards way of saying the mapping. We can also do it visually. So we could do it graphically. So we could have a point here, 3, 7, on the graph. Or we could do a mapping diagram that looks like this, where we have 3 being mapped to 7 by an arrow. Now, what is a function value? A function value is the resulting range value, so the y value, after a given domain value is selected that makes the function true. So in order to find a function value, we're going to plug in the given value for x. So whatever they tell us they want for x, the function value is the result or the output. So for instance, if I have f of 3 is equal to x minus 5. So all that means is I'm going to take 3 and plug it in, and then the result is what we call the function value. So we plug 3 in for x, and we get 3 minus 5, which is negative 2. So negative 2 is my function value. So finding a function value from a graph. So which of the following letters represents f of 4? So I'm going to go here to where x is 4, which is here. So notice I have f of 4 is represented by this dotted line p here. So it's right there. And we would say then that p represents f of 4. Now if it asks for the actual solution, then that would be c. So p is our answer in this one. Now if it actually gives us the value, so 2, f of 2. So here we would say f of 2, which is right here, and x is actually 2, so that means that we're going to select the actual point on the graph, which in this case is D. So if you see something like this in coordinate form, you're going to find the actual point on the graph. If you see it and it's just this part, like f of 2, it's going to be the value on the dotted line, which would have been b. Now, how do we find a function value from an actual equation? So it says, what is the function value for f of 6 for the function f of x is equal to 2x minus 5? So what we're going to do is we're going to take f of x equals 2 minus 5, and we're going to plug 6 in for x. So it goes here and here. So f of 6 is equal to 2 times 6 minus 5. Well, 2 times 6 is 12. 12 minus 5 is 7. So the function value for f of 6 is 7. Now let's take a look at how we can compare function values. So this question says, is h of 1 greater than h of 2? So if we find where x is 1, which is here, is that greater than when it's 2, which is here? Well, we can see that this spot is higher, so that is not true. So no, h of 1 is less than h of 2. Here's another question. Is h of negative 0.5 positive? So negative 1/2, which is about right here somewhere. Is it positive? Well, we can see that it is. It's above the x-axis, so yes, it's positive. Now, how many numbers map to 1? Well, remember when we say map to 1, that means that y is 1, so there's 1, 2 values there. There's 3, 4, 5 values that map to 1. So there are 5 numbers that map to 1. So these are the types of questions that you could see on your assignment today. Now, what is a periodic function? A periodic function is a function whose graph has a repeating pattern, so it's constantly just starting over again. So think of a rotating fan. So those oscillating fans, they go all the way to the left, then they stop and come all the way back to the right, then go all the way back to the left, and they just keep doing the same pattern over and over again. A period is the length of the repeating section. So how long does it take for it to start back over again? So to calculate the period, you're going to count the distance the graph travels before it begins to repeat itself. So whatever the pattern is, so it goes up and then down and then starts over again, then up and then down and so on. So when does it get back to its original starting point? So an example of this. So we have this funny little pattern here. And it gets here, and then, but once it gets back to this point right here, it starts over and does the exact same pattern. Then comes back up, starts over again, does the exact same pattern. Same thing here. This one goes up, comes back down. Right here, it starts over again. Here and up, here and again. Same thing here now. This one is a little different because it's getting larger each time, but it's still keeping a pattern of up and down and up and down. So what are the periods of the function? Well, we can see that from here to right about there, it's doing something different. It's unique. Then once it gets to here, it starts over again. So we would say that this is our pattern, which has a period of about 2. Then here, we go up and then down, and right here, we start over again. So this one has a period of about 3. And this one goes from the top down here and then starts over again. So this one has a period of about 2. Now, how do we perform operations on function values? So let's say, given the table above, what is f of 2 minus g of 1? So what that means is we're going to find what f of 2 is and then subtract g of 1 from it. So f of 2, if we look at f of 2, we can see that the value here is negative 2. So when x is 2, y is negative 2. So we keep that there. And then we look at g. So g of 1, which is here, when g is 1, the g of x is negative 1/2. So we take those two values, and then we're just going to subtract them, just like it says. So f of 2 minus g of 1 is the same thing as negative 2 minus negative 0.5, which is really plus positive 0.5. And we get negative 1.5 as our solution. Let's look at another example. So this one says, what is 4 times h of negative 2? So if we take h, so when h is negative 2, y is 4. So there's our value. And then we want 4 times that. So 4h of negative 2 is the same thing as 4 times 4. And 4 times 4 is 16. Now let's look at another example. So it says, what is f plus g of 2? Well, when we write that out, f plus g of 2 is the same thing as f of 2 plus g of 2. So when we do that, we find f of 2, which is negative 2, and g of 2, which is 1. And then we're just going to add those two together. So we add up negative 2 plus 1, which is negative 1. So when we do this and you see f plus g or f minus g or anything like that, really what that's saying is we're going to take f of this value and then whatever operation's there and then g of that number. So let's see another example of this. This time we have fg of 8. Well, fg just means multiplication, so really we can break that up and it becomes f of 8 times g of 8. So f of 8 in this case is 40, and g of 8 is right here, which is 4. So now we just multiply these together and we get 40 times 4, which is 160. Let's take a look now at the reasoning with representations of functions review part 3 assignment. The assignment begins with the learning goals and success criteria. If we scroll down, we can see the questions. The first one says, which of the following is not an accurate representation of the mapping below? So it says that g maps 0 to 2. So g of 0 is equal to 2. That's correct. 0 is mapped to 2 by the function g. That's correct as well. The point 0, 2 belongs to the graph of the function g. That's correct as well. 2 is the image of 0. That's correct. So all of them are correct representations. Then we'll go ahead and go to the next one. It says, which of the following letters represents f of 1? So that means when x is 1, what is y? Well, it's right here. So f of 1 is just this part right here, which is e. So lowercase e. And we'll continue to answer each of these questions until we get to the end of the assignment. When you get to the end of the assignment, go ahead and click next. This will take you to your before you go. Go ahead and fill out your before you go and then submit your work on Google Classroom.